Hello. We're here to talk about network privacy, which is important because Zcash chain privacy means that the network might be an attacker's only option. I'm your host, Alan Fairless. I serve on the board of the electric coin company, now Bootstrap. The panelists are Janito Vaqueiro, who recently joined the Zcash Foundation as a developer and has a background in the VPN industry. Then Julia Fonte, who's a professor at Carnegie Mellon, and her research includes attacks and defenses on cryptocurrency peer-to-peer networks. Finally, George Kadianakis has been a Tor developer for over a decade, and that whole time he's been traveling with an onion inside his luggage. All right, so panelists, is it okay if we start with something fun? All right, great. I'd like to ask you, what are the operational security tactics you personally use to improve network privacy? But wrong answers only. So for example, I make sure to only use HTTP so I can inspect all the traffic. Janito, let's start with you. Bad network advice for us?
Cool. Hello, everyone. So yeah, some bad network advice. I can apply it to a scenario. Consider you're going traveling. And at least when you think about traveling, you think about what hotel you're going to stay. And it's really important to choose the right hotel. So the first thing I do is try to choose the hotel to find one that relaxes me most. So I call them and ask them, does your Wi-Fi have password? Because I mean, if I'm going back after a long day, I don't want to type password or get on the screens to type stuff. So I only want open Wi-Fi. The next thing I want is a smart TV because come on, I only watch things on the internet. So I'm not gonna like browse channels. So that's the most relaxing. And the last thing I also think might be interesting to have in the room is a camera on the TV, because in that case, if I need to call my relatives or something afterwards, it's really easy. I don't have to take out my computer. So I think that's the best scenario. I mean, what could go wrong?
Nice, great advice. All right, Julia, bad advice for us?
Well, I guess unfortunately, my baby recently learned how to unplug our home network router, so packets don't get in or out. So that's pretty good for privacy.
Hey, smart baby figures out how to get the most of mom's attention. Love it. All right, George, how about you?
So, all right, that's legit. So, okay, I have the following thing I did a few weeks ago. I calculated that IPv4 has an incredibly small space. So there's tools like Zmap, which is unrelated to Zcash, that you can basically scan the whole internet and find the IP of people. So what I did to work around this is I went to my router and I set it up to give me IPv6 addresses, which is like much bigger. So this way now Zmap need to take, I don't know, like 6 to the 128 or something huge anyway. So I did this and then, you know, I put like 2 routers on top of each other. So now I have double the search space. And this way I'm practically invisible on the internet.
All right, George. Well, I'm glad we could find you today. Okay, so turning to more serious topics, let's start with the threat model. So from the network, what are the top 2 or 3 specific threats Zcash users face as far as their network learning information that should stay private? What are the main risks? Julia, let's start with you.
Sure, yeah. So I think when we're thinking about risks to network privacy, it's important to think about 3 different things. One is what's the goal of the adversary? One is what are the adversary's capabilities? And the third is what kind of system are they actually dealing with? So in terms of the goals, a lot of the privacy risks that we think about are actually pretty similar. So in the anonymity literature, typically we think about 3 different types. One is sender anonymity. So can your transactions be linked to whoever it was that sent it? Receiver anonymity, can you link your transaction to a receiver? And sender-receiver linkability. So can you figure out that this particular transaction was sent from, let's say, Alice to Bob? And the ease or difficulty of doing this depends on a few different factors, including whether or not you're using shielded transactions, which we'll get into later, and what the adversary's capabilities are. So we can think about adversaries that kind of range from very simple ones that are just running a node or running some number of nodes to fairly advanced adversaries like an ISP or even a nation state level adversary. And like all of these combinations of factors lead to different threat models and different types of attacks that are possible. But the end goal is always to try to link transactions to human users.
Makes sense. Great answer. George, Janito, want to jump in? Anything else?
So I've been doing a bit of reading to understand like all these threats of going into the network and doing analysis, how real they are. So one thing I found very interesting is that like the environment is very adversarial in terms of network privacy. So like even 6 years ago, Chainalysis set up a bunch of nodes on the Bitcoin network, gathering IP addresses. And that was like 6 years ago. So I don't know what's going on right now, but like the setup is definitely adversarial and the adversaries are advancing for sure. And another thing is like on the defense side that I find quite interesting is that people actually care about network privacy. So for example, in the Bitcoin network, you can see that from the full nodes, so kind of like the power users of the network, about 20% of them are running behind Tor Onion services, and this has ranged between 25%. So like at some point, 1/4 of all the full nodes were behind Onion services. So it's clear that both attackers and defenders really care in this case, and I find this quite interesting.
I just wanted to add also the amount that you're transferring is also a privacy thing you probably want to hide, and it's not exactly related to network privacy, but I think there might be a small relationship that I thought about. Consider, for example, if there's a flaw in the definition of the protocol, and you can do replay attacks, for example. I think that has happened before, like in the early days of cryptocurrencies. I'm not sure with what chain, but that's something that's obviously everyone knows about. But consider, for example, if that still happened, you could replay, if you're the one that received the transaction, you could replay it to get more money. And you can also find out how much money there was in the sender address in the first place. So that might be another thing that's related, but obviously it's a smaller relationship.
Nice. And how do these risks compare? How does Zcash compare with other cryptocurrencies as far as these risks?
So, all right. So another thing I want to say on the previous question is with regards to like light wallets. And this is basically what most people are using right now. They use light wallet. They don't set up like a huge multi-gigabyte thing on their mobile phone. So light wallets also offer a pretty juicy target for network adversaries, because basically all your transactions go to a single server, and anyone who has that server or anyone who observes that server can learn metadata. So it's basically, this thing is a mess in general, and it's like in other blockchains. So for example, like in Ethereum, which is based on the whole like node protocol is based on UDP. You don't even have the option of using Tor or Tor-like TCP-based services. So there, the light wallet protocol that uses Infura has even more metadata about people. It basically dominates the whole information space, and the whole light wallet space is also very scary in pretty much all the blockchains.
Yeah, that's a good point. It's like, things are kind of great when we're on network and broadcasting, desktop and all the information is going to all the users. But then for some reason, we want to conserve bandwidth and battery on our cell phones, and things get more complicated.
I think, at least in my opinion, Zcash is it's on the right path because there are already more protection, more privacy, like by default, but also there's this strong culture and thinking about privacy that's also applying to network privacy. So there are discussions about how to improve that constantly. And I think that's good as well. So comparing to other chains, just the fact that you have a privacy culture already gives you sort of an advantage to keep improving it. So I think that's also, and I also think we're already on a good place, but it's obviously going to get better. And I think with the ZOMG grant that came yesterday, that also improves and sets the path forward. But maybe George can say more about that. I'm not sure.
Yeah, definitely. So basically, one thing that happened recently is that we, Tor, received a huge amount of money from the ZOMG foundation organization to fund the RT project, which is basically the Rust implementation of the Tor client. It's basically the future for Tor implementations in terms of both, binary security, memory safety, and all that stuff, but also it paves the way to do further integration into, it becomes much more lightweight, much more modular. So using this in the future, we can integrate much better into other products that need privacy.
I think one other example that's maybe useful to think about, I agree with everything that Janito and George said, is related to like what's one specific attack that is easy on, say, something like Bitcoin, but harder on something like Zcash. And I think one example of that is what I mentioned earlier, which is sender anonymity. So like, let's suppose you have an adversary who's trying to figure out who is the sender of a particular transaction. What they can do is to set up a bunch of nodes that are sitting in the peer-to-peer network and listening for a given transaction and looking at what IP address delivered that transaction to them. And based on that information, they can often infer what was the source IP that originated the transaction. And actually, this is using techniques that are kind of similar to the way that we track a patient zero from epidemics. So this is something that's pretty straightforward to do in a network like Bitcoin. And it's actually also straightforward to do in a network like Zcash. But the difference is that if you're using a shielded transaction, knowing the source IP of that transaction doesn't give you as much information because you can't actually see the contents of the transaction. So I think that's one big difference between the way that Zcash is implementing things and the way that we might see it in other cryptocurrencies. The caveat here, of course, is that most transactions are not actually shielded. So this is a risk also in Zcash, but they at least have mechanisms built in to address some of this.
If I may sit on this topic for a bit more, I just want to say that like another hobby I have is the proof of stake protocols. I don't know what's the opinion about proof of stake in this conference, but I really enjoy the whole idea. So, all right. Okay, so a thing that I found very interesting is that in proof of stake protocols, network privacy becomes even more central to the idea and to the security of the protocol. So, and that's for at least two reasons. So one reason is that, in proof of work protocols, you can sit in a basement somewhere, hammer your GPUs, and then send out the winning block. And you do this in a broadcast way, and you don't have to deal much with the rest of the network. Whereas with like a proof of stake protocol, you have a more, as a validator, you have a more long-term connection with the rest of the P2P network, and you have a more like long-term identity through which you validate things, you get reward. It's not like a hide, push, hide situation. So there are at least two interesting things in terms of network privacy. One is that if you know who is going to be the next proposer, validator, and you know that they're going to be responsible for the next block, you can denial of service them, and this way you block the protocol for at least one round. So there is security implications, but also when you're a more like pseudonymous permanent identity and also part of the blockchain, then in theory you could become responsible for the blocks you mine. So in theory, if they know your identity and you mine illegal transactions, you might be considered to be doing illegal things, basically. So the network privacy, at least in my understanding, and validator privacy becomes extremely more important in proof of stake protocols, and that's why they're coming up with like secret leader election protocols and much more sophisticated things. I don't know if I'm diverging, but this is just something I noticed recently.
Well, it's an interesting divergence, and I know there's interest among the Zcash community to explore other options. I think we heard yesterday that there's particularly interest around how proof of stake makes some complications around Zcash shielded assets go away, or at least mitigate. So there's interest from multiple angles aside from the obvious ones. But what I'm hearing is that network privacy is super important. We can't ignore it. It's a real problem. It's affecting users today, particularly users on mobile. So it's good that we're bringing people together about that. So going back to comparing Zcash to other cryptocurrencies, is there any cryptocurrency that's ahead of us in this regard that's doing really well at network level privacy? Or is Zcash kind of at the head based on its chain privacy add-on effects?
For me, the honest answer is I don't know, to be sure. I know there's at least one other coin that's also privacy related and also focusing on improving network privacy. I think it's Moderator, if I'm not mistaken. They are using something like integrating I2P. I'm not exactly sure the details, but it's good to have more, but it's not enough. I think, I mean, it would be best if it would be like obviously all chains focusing on network privacy, because then we can all cross-pollinate. But I think there's not much, and I can't tell who's ahead, to be honest. I'm not sure.
Makes sense. And yeah, in some leading discussions prior to this meeting, I learned that some of the same attacks that we've talked about today, or some of the same information leaks, also apply to Monero and other privacy coins. So yeah, my understanding is that there's not a clear winner yet. But everybody has work to do. All right, so
I'm also not super up to date on what the latest that Monero has done, but I believe they, in addition to being in the process of implementing I2P, they also implemented Dandelion recently, which doesn't tackle like all of the network privacy questions at all, but it is one step in that direction. So I don't.
Interesting. And Dandelion has come up in some of the research that I know Electric Coin Company has looked at and otherwise. Do you want to give a brief overview of it?
Yeah, sure. So the key idea behind Dandelion is to change how transactions are propagated over the peer-to-peer network. So typically in these peer-to-peer networks, starting with Bitcoin and extending to a lot of the other cryptocurrencies that forked Bitcoin, transactions would be propagated in what's called the diffusion process. So basically, if you think of a pebble that gets dropped in a pool and the ripples start spreading out symmetrically around that pebble, that's kind of how transactions spread on these peer-to-peer networks. So I start a transaction, I spread it to my neighbors on the peer-to-peer graph, they spread it to their neighbors and so forth. And the problem is that this is really symmetric, which makes it easy for network observers to basically triangulate, figure out where the center of that ripple was. So the key idea behind Dandelion is to transmit transactions in an asymmetric way first, so over a few random hops, and then you start this diffusion process or this symmetric spreading. So it has some similarities to the ideas behind Tor, behind onion routing, as well as other anonymity protocols in the past. But yeah, that's the key idea.
Nice. All right. Well, that's probably a good segue. Before we get into what are the solutions, let's talk about what are some approaches users take to privacy that don't actually work that well, or that are sometimes proposed as solutions at network or application layers that aren't super effective.
So I hate to go with a classic, like it depends on the user threat model. answer, but like, in my opinion, I used to love reading like opsec fails and try to understand how people fail doing things. And like usually what happens is that people go outside of their threat model depth, and that's where they fail kind of. So it can go both ways, I think. It can go either like, you are you have very advanced adversaries and you didn't do due diligence. So you didn't set up your Tor correctly, and like, you know, instead of doing Tor to VPN, you went VPN to Tor, or some other like basic mistake that at that point didn't make sense, but that ended up into jail. Or it can also go the other way around. Like, you know, I have friends who were like, you know, maybe they don't have a serious adversary, but then, you know, like they watch the Snowden movie, and then they're like, you know, I now switched to Tor and I used 12 hops and I burned my mobile phone and I don't use, and, you know, they go to the extreme level. And then I noticed that after like a bunch of days, weeks, they just fall back to the normal reality because they kind of overshoot their threat model, you know? And I'm just trying to say that, you know, the threat model is important in all these things. And after a certain point of user threat, you need to start understanding, unfortunately, you need to start understanding more about the tech you're using and try to predict the fails that you might do.
I have an interesting story related to this, because what you said is all true, but there's like this small issue, which is UX related. And there's a story that I heard that there's this user that heard that VPN was great to start becoming more private. So they installed it, but then they went to check if they were safe, and they weren't, and they complained. But then they realized that they didn't press the connect button on the VPN app. So, I mean, it's just one step, but that's one step more that they have to do instead of like not being private. And what I mean is, it's kind of an arms race, because UX is very important to make everything work, and making the connection to Zcash, like having transparent address by default, is like a very similar situation. So the user must know what they're doing, but it's also a burden to them that we can't expect them to know what they're doing like from the start. And I'm thinking this more of as an arms race, because on one hand you have like, you want to guarantee privacy, and the other hand you have like third parties that want to get your data. And on the privacy side, you have enthusiasts and activists. On the data collection side, there's money, and I mean like trillion dollar companies. So it's like it's a very different balance, and that's why to give your data to someone, to some third party, what you have to do in terms of UX, you have to do absolutely nothing. As soon as you open your browser and start typing anything, it's already going to some company. So that's the level of difficulty we're competing against. And I think it's not just like activist fighting. I think governments are also focusing on this. And one good step is like the cookie banner. I know it's annoying for everyone, but it shows like there's an extra step to collect your data. And I mean, it's not good enough making one UX worse. You actually have to make privacy easy and accessible to everyone. So I think that's also very important and related to the discussion we're having.
So if you put privacy behind a button, we can expect lots of users to not get there. Total agreement. Okay, well, one more specific example, since we're talking a lot about Tor and understanding your threat model and the tools and the technologies, like, so, you know, everybody understands that, you know, Tor provides network anonymity, but one of the weaknesses is local traffic analysis. Like if you're using Tor, but your ISP can monitor when you're sending and receiving, then there's a whole new category of attacks that open up that Tor, you know, even though you're using it, doesn't have the opportunity to help you with. So do you want to talk a little bit about, you know, specific solutions versus threats and how they pair up?
All right. So in general, I haven't had too much time to think about like what's the most proper way to do network privacy in blockchains. I understand that end-to-end correlation attacks, as they work in like websites or messaging or kind of low latency environments, they, as you described, so basically you have a listener on one side and on the other, and they can do like timing correlation. I'm wondering how these attacks would work on a blockchain level, because you know, on a blockchain, when you send a transaction, it doesn't go to the other side immediately. It needs to go through the mempool. A bunch of seconds, minutes need to pass. So I think thinking of how these old or low latency end-to-end correlation attacks apply on the blockchain transaction setting for clients is quite complicated. Yeah, I would need to understand more about the environment and to give a better explanation of how these attacks would work in this setting.
Yeah, I guess part of the problem is just that the block times are so long relative to like network latency. Your signal to noise ratio gets pretty bad very quickly. So it gets harder to do these kinds of end-to-end correlations.
Right, but then, you know, like it also goes into the light wallet. So what happens if the light wallet, you're using a light wallet and the light wallet is your adversary, because then your destination is not like a block through a P2P network, and it's not so complicated. You know, the destination is much more streamlined, and there, you know, attacks like that might be more possible. There might be padding, so like sending fake traffic to confuse attackers and kind of, you know, like instead of sending a transaction at only when you need it, and then the adversary can correlate that time, you can constantly send transactions to kind of diffuse the time that you did it. It's a pretty complicated setting that needs thorough analysis, I would say.
Yeah, there's been a lot of work in the like anti-censorship literature on these kinds of approaches of like sending cover traffic. I guess none of it has like really taken off. I guess because of the associated inefficiency, but at least to my knowledge. But yeah, it's definitely a tricky question. I don't think we have clear answers on how to solve these problems.
On this note, on the traffic padding thing, one thing we did recently with Tor is we made a traffic padding framework inside Tor, which you can program using state machines, and that kind of allows you to do more advanced adaptive padding. So you can kind of program what you want the padding to look like, and that's going to fly over the circuits you do. It's not used for many things yet. The original idea was to hide onion services, but I believe that you can kind of model the transaction flow as a state machine and kind of use such adaptive frameworks to provide cover traffic in these cases.
Nice. One of the other solutions that I've seen proposed is a constant bandwidth protocol when interacting with the light wallet D or the network.
Right.
Yeah,
yep.
That's really helpful in terms of privacy, but it's also a trade-off in terms of UX, because, for example, if you do that on a mobile, you're using more data, and depending on like the infrastructure of, for example, what country you're in, that might be important to the user. So they might opt out of using more privacy. So it's always a trade-off, and that's a hard part.
Yeah, good point. Okay, so let's actually talk specifically about the trade-offs. So what are the common trade-offs that new technologies typically make in exchange for better network privacy? And how should users or system designers evaluate those trade-offs?
I think it's usually some combination of bandwidth and latency is usually the price of the solutions that we see. So for example, if you're changing your, like I mentioned earlier, these diffusion protocols for disseminating transactions. The reason we use that is because that's the fastest way to get transactions to everyone in the network. So if you start changing that, either by like routing your transactions through Tor or by using something like Dandelion, you're going to add additional latency. The other solutions that we've been talking about, like adding covered traffic, these things have additional bandwidth costs, which might be trivial to people in certain situations, but could be actually pretty substantial to people in others. So I think those are the two big ones that come to mind.
On this trade-off between bandwidth and latency, I think what is worth being said is that and that kind of fit also on the previous question, is the conversation about mixnets, where mixnets are like higher latency anonymity tools, where you basically trade off time for advanced security, so for some advanced security properties. Using mixnets in blockchains would be another way to investigate network privacy. Of course, mixnets also come with complications. There are attacks that work on mixnets and they don't work on low latency. It's also a complicated field, basically. Janito?
Yeah, I just wanted to add that this trade-off is also not, you can't just choose one by default, because consider, for example, for users, it's great to have more privacy. But for example, if we're talking about like more decentralized finance, adding latency, you can lose money. So that's also an issue, and it's hard to like attend all users in different ways. So it's hard. Just what I'm saying.
And there is a question from the audience, as it seems.
Yeah, what guarantees does Tor provide versus Dandelion? How do those two technologies, what threats do those technologies address, and how do they work together?
I can start with the guarantees that Dandelion provides. So the analysis for Dandelion is considering two anonymity metrics, precision and recall. So we're assuming we have an adversary who's trying to link transactions to the sender. So in that sense, it's a kind of similar, it's tackling a very similar problem to what Tor is doing. Theoretically, we show some lower bounds on what precision and recall are possible, and show that Dandelion comes within a logarithmic factor of those lower bounds. So a long way of saying, we show some mathematical guarantees that Dandelion is doing as well as you can for an anonymity protocol that is happening entirely within the peer-to-peer network itself. Now, when you compare that with Tor, maybe George can talk a little bit more about this, but it's kind of a different model because you're actually moving outside the network itself to a third party. So that has its own set of trade-offs. But in terms of the actual theoretical guarantees, it's a little bit difficult to compare, even though they are tackling the same problem. I don't know if you have anything you want to add to that, George.
So actually, I again, it's a field that I'm not super familiar with, but one thing that I've been thinking about is that they are tackling a similar problem, which is how to hide identities inside the P2P network, but they're also complementary in a sense, because the way I see it is that on the network privacy, so like before you reach the blockchain, while you're traveling inside the P2P network, there is multiple ways to get identified. So one way is for your adversary to catch you as you're flying in the network. And that's where Tor is useful, because that's where it protects you against. But once you're inside the network, the way your information propagates, that's where Dandelion is more useful in. And I think you know, Dandelion has this sort of like logic where your transactions are less promiscuous and they go to less people. But I think these two technologies could be combined together. So you can use Tor to get inside, and then you can use Dandelion to be more private, so that less people inside the P2P network can gather metadata. So they cannot say, it's this, it's going through the direction of that P2P node. I think that's the way I see it. Maybe it's wrong, but I've been seeing them as complementary and not as you know, one or the other necessarily.
Sure, I think that makes sense. Yeah, like Dandelion is weakening the correlation between the propagation trajectory and whatever node in the network is starting that trajectory. So one could, in principle, use both.
All right, so and those two seem to mostly address send privacy. And so on the separate side, it's, you know, receive privacy. Like if I'm receiving transactions and one of those transactions involves a memo that's to me, and I'm receiving these over the Light Wallet protocol, and I want to get that memo, then, you know, do I risk making a network transaction that identified that memo, that what I downloaded included a memo for me, or, you know, do I do it in some other way? So I kind of classify the taxonomy is the threat mobile or desktop, and is it send or receive? And, you know, which are the different technologies that apply in each one of those ways? And, you know, are they complementary? Do we layer them? If we layer them, do they, you know, increase the latency, you know, additively, or do they work in an efficient way together? All right, so moving on. Separately from changing the underlying network technology, what are the UX changes that could help improve network privacy as far as guiding users to safer behaviors? So things like wallet or exchange UIs, default settings, things like that.
So, all right, I can do a start here. So talking about opsec fails before, one classic opsec fail is you download Tor browser, you use Tor browser, and then you think that your whole computer is anonymous. You know, that's a classic. And this thing, like, I remember very old back in Electrum wallet for Bitcoin, when you had to set up your SOX proxy to use Tor, you had to do it by hand. So specify the local host and the port. And, you know, like, I'm a Tor developer and I don't even remember which port Tor sits in. So it's like this sort of zero configuration thing is extremely important for me. And, you know, you want your wallet or the tool that you use to do the things that you expect in terms of network privacy without you needing to put random numbers in some random settings box. And that's also a thing that I want to touch more before with the Rust implementation of Tor, and how this will make it integrate much nicer with such tools. Because right now, Tor is extremely clunky. It's a huge C code base. It's really hard to shove inside another project. But with this new implementation, it's going to be much easier to integrate in various settings. And we're doing this with an integration mindset from the beginning. And I think that's quite important.
Yeah, and I love that it's another great example of cryptocurrency funding open source technology that makes things better for everyone. All right, well, in the 5 minutes that we have left, we have one more audience question. What are the pros and cons of using a Mixnet to enter the peer-to-peer network versus Tor?
All right, I guess I'm expected to answer this. Okay, right. So, okay, so I guess the pros of using Tor in this case is that you get the low latency. So, for example, in various settings in the blockchain, low latency might be important. So if we're talking about, people trying to do stuff before the next block comes in, you want to be fast. You cannot afford a whole Mixnet blend round. So low latency might be important in some use cases, and in others it might not be. So for example, perhaps using a Mixnet might be fine if you want a transaction to go through and you don't care if it's now or in 2 hours or in 15 minutes. I don't know. It depends on the Mixnet setting. That's also a big discussion of how big the Mixnet delay should be. Another big pro of using Tor is that it exists and it's a huge network with a huge anonymity set, whereas Mixnets don't really exist. So that's like a bit of an existential thing. Yeah, so I don't know. It would depend on the precise Mixnet and the delays and how long it takes to propagate through the hops to kind of talk about how the user experience would look like using a Mixnet. Anyone else who wants to touch on this?
Yeah, I think you mentioned the two important ones, which are latency and usability. Sorry, three, and the anonymity set. I'm reminded of an example of a kid from, I think, some Ivy League who called in a bomb threat to his school because he wanted to get out of giving an exam, and he was the only one on his network that was using Tor, and which he had used to call in this bomb threat, and so they figured out immediately that it was him. Thinking about the size of the anonymity set is super important when you're thinking about privacy, and also making privacy tools as usable as possible and as effortless as possible is a huge part of making an actual impact in this space.
All right, well, let's wrap it up with a future-looking question. So what are the most promising areas for this technology to evolve over, let's say, the next 5 to 10 years, and possibly with more great funding sources?
For me, I think a particular important one is private information retrieval. So that's basically being able to go to a server and ask for information without the server learning what you're asking for. So for example, even with Tor or a magic network privacy tool, if you go to the Light Wallet server and you ask for a specific memo or block, even though your identity is hidden and you're anonymous, the server knows that you're asking for a particular information, and that metadata counts over time. So using PIR, private information retrieval, would be able to defend against this. But right now, as far as I know, it's there are huge trade-offs between bandwidth and latency, and PIR is not as usable in the widespread way.
All right, 1 minute left.
Sorry.
Go ahead, Julia.
Yeah, PIR is pretty heavy today. There has been some interesting lines of work on reducing the costs by spreading the number of servers that are engaging in PIR, with the constraint that all of those servers have to be kind of coordinated with one another. So I think some interesting research questions are surrounding doing PIR when you have databases that are not well synchronized or are in a distributed system. That's a nice area of research.
All right, well, thanks everyone for joining us today. And I'm glad we could bring people from multidisciplinary network backgrounds to look at this problem. And I'll be paying attention to this space in the future. Join us in the chat afterwards.